Hi there and welcome to the course on discrete transforms. We're going to start off by looking at the continuous Fourier transform, and we're going to use that as a lead-in in order to derive the discrete transforms. So we're going to start off with the continuous Fourier transform and we're going to sample it in the time domain. This will give us our discrete-time Fourier transform. Then we'll take the continuous transform and we'll sample it in the frequency domain, and this will give us our discrete frequency Fourier transform, or what is commonly known as the Fourier series. And then we'll take the continuous Fourier transform and we'll sample it in both time and in frequency, and this will give us our discrete Fourier transform, or what is known as commonly the DFT. We'll then look at implementing the DFT in a fast Fourier algorithm. Now the algorithm we're going to use is the radix by 2 decimation in time. So we'll derive that and then we'll implement it in order for you to see it actually working. Now there are other areas that we're going to look at within the video series. So we'll also look at the discrete convolution, we'll look at windowing and leakage, we'll look at the sampling theorem and aliasing, we'll also look at the impulse trains, and we'll see why an impulse train in the time domain gives you an impulse train in the frequency domain. We'll also move on and we'll look at the Z transforms, the discrete cosine transform, the Walsh transform, the Hadard transform, and also a section on wavelet transforms. So at the moment we're finished up to the fast Fourier transform. So I've got about 80% or so of the course done, and we're looking at about 4.5 hours worth so far. So there will be about between 6 and 7 hours in total. Now I'm just about to break up to go for my Christmas break, and when I come back over the first 2 weeks of January, the final 2 or 3 videos of the course will be completed. That's the videos on the Walsh transform, the Hadard transform, and the wavelet transforms. So I was kind of deciding whether to put the course on, as it isn't actually 100% complete, but I have had a few emails and people that have completed a previous course which is in the Fourier and Laplace transforms, asking if I could get the course up for them as soon as possible. So I decided to put the course up. Also, by putting the course up, it makes me work a bit harder and put a bit more time into it in the new year in order to get the course fully completed. Now, when the course is fully completed, we also have the handouts available to you. Now, anyone who has done the course on the Fourier and Laplace transforms, they'll know the type of video that I make. Also know that I try to introduce the subject in a 3D graphical format, as well as going through the mathematics, and this course isn't any different. We continue with the approach that I took with the Fourier and Laplace transforms. So although you don't need to have done the Fourier and Laplace transforms in order to do this course should be self-contained. It will still help, and I will refer to it now and again, but when I do refer to it, I'll ensure that the videos sections that I refer to are freely available to you within Udemy in order for you to go and have a look at them. So that's all there is for this video. I will make a new video in the new year when the course is it's fully completed. If you get any questions, then get in touch and hopefully I can answer them for you. Also, the course will be worked on as time goes by, so over the first couple of months in January, February 2020, I will continue with it, and I'll add in some more video and some more practical content to it. So it's not an absolute finished article, but there's certainly enough in it for now in order to get a good grasp and a good understanding of the mathematics of discrete transforms. Thank you for listening, and I'll get you on the next video. Goodbye.